Yes, sir.
So, what is the source of electromagnetic wave? I have told you in the last class. Okay, so Nida, hello. So, what is the source of electromagnetic wave, Nida? How can we produce the electromagnetic wave? Basically, source of electromagnetic wave is the accelerating or the oscillating charge. Okay, accelerating or oscillating charge. I have told you in the last class. Accelerating or oscillating charge. And oscillation of charge takes place in LC circuit. Okay, so oscillation of charge takes place in LC circuit. So basically today we will discuss something about the wave. Okay, so basics related to wave we have completed in the last class. So this is the wave. This is a sinusoidal wave. So these are the terms related to the wave: wavelength, wave number, time period, frequency, angular frequency, and what is the speed of the wave. Okay. Because we are studying the electromagnetic wave, that is why few property of the wave we should know. And there is one more relation: speed of the wave is equal to frequency of the wave into the wavelength of the wave. So this thing should know by you. Okay, so now we will write the equation of the wave. Equation of the wave. Equation of wave. Equation of wave. Basically, equation of wave is just the equation of the displacement of the particle. Okay, is basically the displacement of the particle in the wave. Displacement of particle. For example, I have this wave. This wave I have. Okay, so in this wave, there are different particles. There are different particles. Suppose one particle is here. Here is one particle, and this particle this time, okay, is moving in the upward direction, and here is another particle. This particle is going in the downward direction, and this particle is moving in the upward direction. This is particle P1, this is particle P2. There will be another particle here, and that particle will move in upward direction, will oscillate in upward direction. Oscillate. This is P3, suppose. This is particle P1, oscillate like this. Right now, this particle is going in upward direction, upward y direction, positive y direction. This particle P2. So basically, particle oscillate about its mean position. What is the mean position? This is the mean position. So particle in a wave oscillates like this. Okay, so these particles are oscillating. Okay, so basically these are the particles. So we can say here is the y, here is x. So basically we can say at different positions, the displacement of the particle is different. Okay, see at this x the particle have this much displacement, see at this position the particle have this much displacement. Okay, if you are taking a particle here, suppose here if you have taken a particle, so here the displacement of particle will be this. Okay, suppose this is particle p3. So with distance the displacement of the particle is changing. So you can say y will be a function of x. Okay, y will be a function of x. So you can say that displacement of particle changes with x changes with x. Now as the time changes, now see here, see this particle only. With respect to the time, the displacement of the particle is changing. Suppose at time t1 the particle is here, another time the particle is here. So with time also the displacement of the particle is changing. So you can say y is also a function of time. Y is also a function of time. So you can say displacement of particle changes with time. T is the time. So basically displacement of the particle in a wave, displacement of the particle in a wave is a function of x into time, we can write, and this wave is sinusoidal wave, and this wave is sinusoidal wave, sinusoidal. Okay, sinusoidal. So equation of this wave will depend upon x and time. Sinusoidal because this is in the form of the sine curve. This is that is why this is a sinusoidal wave, and the equation of this wave will depend upon the sine obviously, and with time and with distance also. So equation of the wave can be written as, equation of the wave is basically the displacement of the particle. So equation of the wave you can write y is equal to a sine kx plus minus omega t, plus minus omega t. Or you can write the equation of wave like this: y is equal to a sine omega t plus minus kx. Okay, plus minus kx. So this is the equation of the wave. If suppose uh, now I am telling all the related terms here. Okay, hello Fawaz. Fawaz, how are you?
Yeah, I'm fine.
Okay, so we are discussing what is wave basically and how to write the equation of the wave. Okay, because we want to write the equation of electromagnetic wave. Okay, so if I will say that if it is written that y is equal to a sine omega t plus kx plus kx, so it means that if in between omega t and kx there is plus sign, then you will say that this wave is traveling in negative x direction. Okay, so wave traveling in negative x direction, wave traveling minus x direction. If it is written that y is equal to a sine omega t minus kx, so from this minus sign you can say wave traveling in plus x direction, and this kx will decide the direction of the propagation of the wave. Okay, now we will see the equation of the electromagnetic wave. Equation of EMW means electromagnetic wave. I have told you in electromagnetic wave there is electric field and there is magnetic field. There is electric field and there is magnetic field, and they are oscillating. There is oscillating electric field as well as there is oscillating magnetic field. So this is how the electromagnetic wave looks like. Okay. So basically electric field, this is the electric field direction and this is the magnetic field direction. Okay, and this direction is basically y direction and this direction is basically z direction and this direction is basically x direction. So basically electric field is oscillating along the y axis, magnetic field is oscillating along z axis, and the direction of the propagation of the wave is along x axis. Remember this point. Okay, so what is the meaning of y axis? Y axis means along the j cap. What is the meaning of x axis? I cap. What is the meaning of z axis? K cap. These are the unit vectors. These are the unit vectors. Okay. So if we want to write the equation of the electromagnetic wave is basically the oscillating electric field and oscillating magnetic field. So basically we will write the equation of oscillating electric field and oscillating magnetic field. So first we will write the equation of electromagnetic wave for the oscillating electric field. Okay, so basically here we will have this, suppose, and I have told you the electric field will be along the y direction. This is the electric field direction. Okay, this is the electric field direction and this is the direction of the propagation of the wave. So electric field is along y axis means j cap and direction of the propagation is along I cap. So remember this point. So equation of the electromagnetic wave in terms of the electric field is given by electric field is along y axis. So you will write electric field along y axis. Ey is equal to E naught sine kx minus omega t, and you can write it as j cap also. So this is basically the equation of the electric field in the electromagnetic wave. Okay, so basically here along the x direction, this is the x direction, suppose this is the y direction and this is the z direction. X, y. Along the x direction there is a propagation of the wave, along the y direction there is the electric field, along the z direction there is magnetic field, we have assumed earlier. Okay, so this is the equation of the electromagnetic wave. Now we will modify it. What this wave indicate? Basically this kx, x is representing this wave is propagating along the x axis. Okay, and this j cap is representing the electric field vector is oscillating along the y axis. Now we can modify it. This is Ey is equal to E naught sine k, we can write 2 pi by lambda. K is the wave number. K is the wave number. K is the wave number. We can write it as 2 pi by lambda. Okay. So we can write it as 2 pi by lambda. So it will become 2 pi by lambda into x minus omega can be written as 2 pi by t. Omega can be written as 2 pi by t into t and j cap. You can see here omega we can write as 2 pi by t. Okay. I have not written here. When you will compare it from here, there is a relation between the omega and the time period. So omega can be written as 2 pi by t. Okay. So basically from here you will get this expression from this equation. You will put here f is equal to 1 by t, then you will get omega is equal to 2 pi by t. Now 2 pi take common, ey is equal to e naught sine, and take 2 pi common. So what you will have? You will have xy lambda minus t by capital T and j cap. And what is 1 upon time period? 1 upon time period is equal to frequency. So we can write Ey is equal to E naught sine 2 pi xy lambda minus t into f. 1 by t, instead of 1 by t I have written frequency. Okay, so in this wave, what are these values? In this y is equal to a sine kx plus omega d, what are the values? So basically here this y is the displacement of the particle. We know what is y? Displacement of particle. What is a? A is the maximum displacement of the particle, and this is known as the amplitude. Omega, you know, angular frequency. T is time, k is the wave number, x is the displacement along x-axis. Displacement along x-axis. So remember these points. Now this is the equation of the electric field. Okay, equation of the electric field. Basically, in electromagnetic wave we have the electric field and the magnetic field. So basically this is the equation of the electric field. Okay, how the electric field vector oscillate. This is the electric field, and here E naught is the maximum value of the electric field or amplitude of the electric field. So electric field will vary like this. Okay, here like this and like this, like this. So basically with time the direction and the magnitude of the electric field will change. Okay, so this maximum value of electric field is the amplitude of the electric field. E naught is basically the maximum value of the electric field. I am writing here E naught. E naught will be the amplitude of electric field. Amplitude, or you can say maximum value of the electric field in electromagnetic wave. Maximum value. Now we will write the equation of the magnetic field. Like the electric field, you can see here electric field is oscillating. Sometimes electric field is decreasing, sometimes increasing. With time the electric field is changing. Electric field is changing in magnitude as well as direction. Okay, so like the electric field is oscillating, magnetic field is also oscillating in the same way, but perpendicular to the electric field. Okay, but perpendicular to the electric field. Now here is the magnetic field, and this is the direction of the propagation. This is the direction of the propagation. So magnetic field we have taken along the z-axis. Suppose this is the z-axis, means k cap. So magnetic field is along k cap. Okay, now magnetic field is also oscillating like this. Okay, like the electric field, magnetic field is also oscillating. So suppose this is V naught. So V naught is the maximum value of magnetic field. Maximum value of magnetic field. So same as that of electric field, the equation of magnetic field will be, magnetic field will travel along, magnetic field will oscillate along the z direction. So we will write V suffix z is equal to V naught sine kx minus omega t, kx minus omega t into k cap. Why k cap? Because k cap is representing the direction of oscillation of magnetic field. Okay. And further you can change this equation with the help of the formulas. Okay. Okay. Fawaz and Hamza and Nida, write down, all of you. Basically, equation of the wave is the equation of the displacement of the particle, and displacement of the particle is changing with respect to the distance, with respect to the time. So in electromagnetic wave, electric field is also changing with time, magnetic field is also changing with time. You can say that it is oscillating. Fawaz, are you getting my voice?
Yes, sir.
It's okay.
Yes, sir.
uh, Hamza, I think there is problem in your earphones or headphones. But you note down, all of you. Okay, Hamza, no problem. So Hamza, Nida completed. Internet problem. Okay, so cope up with it. What can I do? What can you do? Fawaz, write down this. Basically, this is a revision of your 11th class. Okay, rejoin. And today we will have a class of 2 hours. Okay, done. Nida, okay, good. Fawaz, completed?
Sir, one sec.
Okay, no problem.
Yes, done, sir.
Okay.
Sir, after wave, what is that written?
After wave,
What is it written? No,
displacement,
no,
displacement of
sir. Down.
wave traveling in x, negative x.
No, after wave arrow is there. After arrow, that sign no.
Mm, This you are saying this?
No, up.
Acha, this
Yeah, yes, sir.
sinusoidal. Sinusoidal. It means that the wave is a function of sine, or the displacement of the particle is a function of sine.
Oh, okay, sir.
Sine is a trigonometric function. Okay, Nida. Hamza, now it's okay, or is still problem? I think there is a problem internet. Fawaz completed?
Yes, sir.
Okay, write down this. So basically, we are considering the electric field is oscillating along y-axis, magnetic field is oscillating along z-axis, and the wave propagation is along x-axis. Completed, Nida? Okay, so write down this. So basically, this will be the equation of the magnetic field vector or magnetic field. Okay. Completed, Fawaz?
Yes, sir.
Okay, so now see. So remember this equation and this equation of magnetic field. This is the equation of magnetic field vector. This is the equation of electric field vector. Sometimes this equation can be changed also. Okay. So according to the situation, the equation of the electric field and the magnetic field will change. Okay. Now there is a relation between the peak value of the electric field and the peak value of the magnetic field. So before that we will solve one question. Before that we will solve one question. Question is the electric field in a plane electromagnetic wave, in a plane electromagnetic wave is given by Ey is equal to 2 sine 0.5 into 10 to the power 3 x plus 1.5 into 10 to the power 11 into t Newton per coulomb. First, they are asking what is the direction of propagation. What is the direction of propagation? Direction of propagation means in which direction the wave is going. Number B part. They are asking the speed of the wave. They are asking speed of wave. Speed of the wave. So basically, this is the electromagnetic wave, and if no medium is given, then speed of the wave is equal to the speed of the light, because light is the electromagnetic wave. So no problem. So one by one we will solve. Answer first. Answer A. This equation of the electric field is given. Equation of the electric field is given. See the equation of the electric field. Basically, equation of the electric field is given. So this is the equation of the electric field. Electric field is along y-axis, and they are asking what is the direction of the propagation of the wave. Here is plus sign. Here is plus sign and here is x. So basically, you can say wave is propagating along negative x-axis. Wave is propagating negative x direction. Why? Basically, this is the equation of the wave. E is equal to E naught. What is the equation of the wave I have written there? Ey is equal to E naught sine kx plus omega t. So if x is there and plus is there, in that case I have told you the wave will propagate along negative x direction.
Sir, minus omega t.
Here is minus omega t. Now I have written here. Here I have written minus omega t, but you can write plus omega t also. I have written in both the ways. Okay, I have written in both the ways. Okay, you can get sometimes if it is written there, it is minus omega t. Sometimes I have told you that it will be plus also. It will be plus means the wave is traveling in negative x direction. Okay. See, I have written here the wave, if the equation is like this, here is plus, the wave is traveling along negative x. If here is minus, the wave is traveling in plus x direction. Okay. So equation of the electric field you can write like this also. E is equal to E naught sine kx plus omega t. Okay. That means your wave will traveling in negative x direction or positive x direction. Okay. So here is this equation you will get. So that is why the wave propagation will be along negative x direction. Speed of the wave. What is the formula of the speed of the wave? You can see from here, speed of the wave is given by omega divided by k. Omega divided by k. So speed of the wave is equal to omega divided by k. This is the speed. So from here, what is omega? Now compare kx. So this value will be k. So your k value will be 0.5 into 10 to the power 3. When you will compare this equation with this equation, this is your kx. K into x. See here, this is kx. And this is omega into t. With t you have omega. So omega is 1.5 into 10 to the power 11. Omega is equal to 1.5 into 10 to the power 11 radian per second. So omega by k, speed of wave you want to find. Na? Speed is equal to omega by k. Omega is 1.5 into 10 to the power 11. K is 0.5 into 10 to the power 3. It will become 3 into 10 to the power 8 meter per second. See, this is the speed of the light also. Okay, this is the speed of the light, because here in this wave no medium is given, so we can just say that the speed of the wave will be the speed of the light in vacuum. Got it, na? Fawaz?
Yes, sir.
So basically you have to compare the equations accordingly. Okay, so now after this, see the graphical representation of the electromagnetic wave. This is the graphical representation. Okay, electric field, magnetic field. Electric field is oscillating along the y-axis, magnetic field is oscillating along z-axis, and direction of the propagation is along x-axis. After that, we will discuss the peak value of the electrical and the magnetic field. What is the relation between the peak value of electric field and the magnetic field? So what is the peak value of the electric field? E naught. E naught is the peak value of electric field, or peak means maximum value of the electric field. Maximum value of electric field. What is V naught? V naught is the peak value or maximum value of magnetic field. There is a relation between the peak value of the electric field and the peak value of the magnetic field. This is given by ratio of peak value of the electric field to the ratio of peak value of the magnetic field is equal to the speed of light in vacuum. Is equal to the speed of light in vacuum. This is the relation between the peak value of the electric field and the magnetic field. Okay, so first what you have to do, you have to write down this, and after that you should write down that. Hello Hamza, now it's fine. Completed for us.
Yes, sir.
Now you should write this. Very good. Was completed. Write down the heading also, peak value of the electric and magnetic field in electromagnetic wave. Basically, these are the electric peak value of the electric field and magnetic field in electromagnetic wave. Okay, you can add here in electromagnetic wave, but it is understood that I am talking about electromagnetic wave. EMW means electromagnetic wave. Okay, next is the permittivity and permeability and permittivity of the free space. Okay, so I think this term you are aware of what is permittivity and what is permeability. So first we will see what will be the what is the relation between the permittivity and permeability for the air, vacuum or free space. For air, vacuum or free space. So there is a relation between the, and I am telling you what is permittivity. So basically C is equal to 1 upon permeability in free space divided and permittivity in free space. What is C? C is the speed of light, in free space, air or vacuum. What is mu naught? Is the permeability of free space, air or vacuum. What is epsilon naught? Is the permittivity of free space. Okay, note down, there is a term relative permeability and relative permittivity. So relative permeability. So relative permeability is represented by mu suffix r. So this mu suffix r is equal to mu m permeability in some medium divided by permeability in free space. Mu m is the permeability of some medium There is a term relative permittivity. In electrostatic you have studied relative permittivity, and this relative permittivity is also known as the dielectric constant. Basically this relative permittivity is represented by epsilon r suffix r or dielectric constant k. So er or k is equal to permittivity in the medium divided by permittivity in free space. Em is the permittivity in medium. Other than the free space or air. Okay, now this is the relation between the speed of light in air and permittivity and permeability in air or free space. Now another relation in other medium other than free space, air and vacuum, the speed of light is equal to 1 upon permeability in that medium and permittivity in that medium. So this is the another relation. So basically what is the speed of the light, or you can say speed of electromagnetic wave. So light is an electromagnetic wave, so you can say speed of electromagnetic wave, or you can say light. So this relation also you have to remember. Okay, so one question we will do. A plane electromagnetic wave, okay, given that Ez is equal to 100 cos 6 into 10 to the power 8 into t plus 4x volt per meter. This is the equation of the wave, propagates in non-magnetic medium, non-magnetic medium of dielectric constant we have to find in this question. First see the equation of the electromagnetic wave. This is the equation of the electric field vector in electromagnetic wave, okay. So this is the equation of the electromagnetic wave. So now this wave is in the form of the cos. This wave is in the form of the cos, okay. So electromagnetic wave or electric field can also be in the form of the cos function, okay. So this time this is in the form of the cos function. Now for calculating the dielectric constant you should know certain things. See how you will solve. What is this? This value will be E naught. This value will be peak value of the electric field, and this value will be omega, and this value will be kx. Now we say E is equal to E naught. With x you will get k, and with t you will get omega. So this is your k. Okay, this is your k. Now speed of wave is equal to omega by k. So what is omega? 6 into 10 to the power 8. And what is k? K is 4. So basically it will become 3 by 2 into 10 to the power 8. So what is 3 into 10 to the power 8? Speed of the light divided by 2. Basically speed of this wave is half of the speed of the light. Suppose this is your equation number 1. Now this wave is traveling in some medium. So we can write that speed of this wave is given by 1 upon permittivity of this permeability of this medium and permittivity of this medium. It is given that here non-magnetic medium. Non-magnetic medium means this medium will have permeability equal to mu naught. Okay, non-magnetic. This medium do not have any magnetic properties. So that is why we are taking permeability of the medium is equal to mu naught. Okay. So instead of mu m, we will take mu naught. So mu m here is equal to mu naught. Why? Non-magnetic medium. Non-magnetic medium. Okay, so we will put this here. V is equal to 1 upon this is mu m. Mu m can be written as mu naught into epsilon m. Epsilon m can be written as, we know that epsilon r or dielectric constant k is equal to em divided by e naught. So em we can write is equal to k into epsilon naught. So we can write here k into epsilon naught. So instead of this v, what is the speed of the wave? C by 2. Speed of the wave is c by 2, and this can be written as 1 upon under root of k times of mu 0 or epsilon 0 or epsilon naught. So what is the speed of the light? Speed of the light in vacuum is given by 1 upon under root mu naught and epsilon naught. So we can write this is c by 2. This is equal to c, and this will become under root k. So basically c and c will be cancelled out. Under root k is equal to 2. So dielectric constant you will get 4. So dielectric constant you will get 4. Just note down, all of you. Hamza, are you getting my voice? Okay, if you are able to listen me, then please take the screenshots.
Yes, sir.
Okay, Fawaz, so I will explain. First, you should write, okay? Then in the last, I will explain the last part. I will explain the question again. No problem. First write, then I will explain. Completed, Fawaz?
Yes, sir.
Okay, so should I scroll down now?
Yes, sir.
Okay. Write down this. So I will explain this question once again, okay? Just wait, first write down, then I will explain. Okay, so Fawaz completed now?
Sir, once again, please.
Okay, okay. Hamza, please take the screenshots if you are listening me.
Done.
Okay, very good. See now, Fawaz. Basically, first I have just calculated the speed of this wave. This is a wave. I have just calculated the speed of the wave, and I got the speed of the wave is equal to half of speed of light in vacuum. Okay, half of speed of light in vacuum. Now, speed of this wave, as this
Sir,
is the
C is speed of light.
C is the speed of light. I think explained here. I have written here. C is the speed of light in
Okay.
free space. So see here, basically this is the half of the C, half of the speed of the light, but in free space. Remember, in free space or in vacuum or in air. Speed of the light can travel in any of the medium. Light can travel in glass also. Light can travel in water also. But the speed of the light will be different. Okay. Now, Fawaz, see here. This I have written because I know this is an electromagnetic wave. So speed of the electromagnetic wave is given by this formula also in terms of the permeability of the medium and permittivity of the medium. And permeability of the medium is given by mu naught. Okay. And permittivity of the medium is k times of the permittivity of the medium in free space. So 1 upon mu naught by under root of mu naught by epsilon naught C. Uh, C is equal to 1 upon under root of mu naught by epsilon naught. This is the value of the C I have put here. So basically it will become C by under root 2. Okay, it will become C by under root K. Here this whole value is C, and here in under root there is a K. C, and this V value we already know. This V value is, we have already calculated half of the C by 2. So okay, so this C and C will cancel out. Under root K is equal to 2 and K is equal to 4. This is very easy question for us now. Okay, got it?
Yes, sir.
So completed all these things.
Yes, sir.
Okay. Now we will discuss energy density of the electromagnetic wave. Energy density of the what is the energy density? We have discussed what is the energy density. Basically, energy density is the energy stored in per unit volume. Okay, is the energy density. So energy density of the electromagnetic wave. Number first, 3 point I will write. So electromagnetic waves carry energy as they travel through space. Travel through space. Thus thus energy is contained in oscillating electrical magnetic field. In oscillating electric and magnetic field. Electric and magnetic field. MF means the magnetic field. Second point, equal amount of energy is contributed by electric and magnetic field. Third point, by now we know that electromagnetic wave produced by oscillating charge and where we get the oscillating charge in LC oscillator, in LC circuit, oscillating charge in LC circuit. So the energy of electric field is from capacitor. Basically LC means inductive capacitive circuit. The energy of the electric field is from capacitor and energy of magnetic field, MF means magnetic field, is from inductor. So energy density, now I will define what is energy density. Energy density of the electric field. So energy density for electric field we will write. Energy density of electric field, this is given by small u into E. Small u into E. For that, just wait a second. This is the one plate of the capacitor. This is the another plate of the capacitor. Okay. And this plate is positively charged and this plate is negatively charged. So what will happen due to that? An electric field will be there in between the plates. Electric field will be there like this. So basically a uniform electric field will be there like this. We know this, na? Here will be the electric field and A is the area of both the plate. Okay, and D is the distance, small d is the distance between the two plates of the capacitor. What are these? This is the plate of capacitor. Plate of capacitor. Okay. Now see, what is the energy stored in the capacitor? Energy stored in the capacitor is given by half CV square. Okay. And what is the capacitance of the parallel plate capacitor? What is the capacitance of the parallel plate capacitor? That is epsilon naught A divided by D. Okay. And here potential difference between the plates of the capacitor is given by electric field into D. Okay. So we will put here the value. Energy is equal to half. Instead of C, I will put epsilon naught A divided by D. And instead of V square, I will write E square into D square. Now see, this D square will be cancelled out with D. So basically you will have U is equal to, energy is equal to half epsilon naught E square into A into D. A into D. And what is A into D? A is the area, D is the distance. This volume will be, this will be the A into D will be the this volume between the plates of the capacitor. So basically AD is the volume. Volume is equal to A, area into distance. So you can write U divided by AD is equal to half epsilon naught into E square. So this is the energy, this is the volume. So energy per unit volume is the energy density. Small u into energy density of the electric field is given by half epsilon naught into electric field between the plates of the capacitor. So this is the energy between the plates of the capacitor. Okay, energy density. This is energy density of electric field. What is this? This is the energy density of electric field But here this electric field, we have seen the equation of the electric field. We have, what is the equation of the electric field? E is equal to E naught sine kx minus omega t, or you can take sine kx plus omega t. So equation of the electric field is, we have E is equal to E naught sine kx minus omega t. So now you can see this electric field is changing. This electric field is changing now. Why this electric field is changing? Because electric field is a function of time and the displacement in x direction. So this electric field is changing, or this. So what we will do, we will put the value of this electric field here. So we will get the energy density of the electric field, small u into E. We will get half epsilon naught is constant, and we will put this value here. So we will get, this is E square now, so we will do square of this. So what we will get, E naught square sine square kx minus omega t. Now this energy density of the electric field is variable. This energy density of electric field is variable or changing with time. So for the variable quantity, we calculate average value. So now we will calculate the average value. We will calculate the average value of the energy density of electric field, average value. So how we calculate the average value? We will write this as bar of half of epsilon naught E naught square sine square kx minus omega t. So basically half is constant, epsilon naught is constant, E naught square is constant. So this will be half epsilon naught E naught square is constant. Now here will be sine square kx minus omega t, and bar on this. Bar means the average value of sine, and I have told you the average value of sine square any theta is equal to half. So the average value of this will be half. So what you will get, what you will get here? Half of epsilon naught E naught square into half. So basically, average value of the energy density of the electric field is equal to 1 by 4th of epsilon naught into E naught square. So this is the average value or energy density of the electric field. So why we are taking the average value? Because the electric field is changing. Okay, because the electric field is changing. So we can find in the same way the energy density for the magnetic field. Energy density for the magnetic field we can find.
Sir, that kx minus omega t.
This value, na?
Yes.
Kx minus.
Yeah.
Just wait. Now see this value, na? You are saying this value kx minus omega t.
Yes, sir.
Basically, this is the electric field in the electromagnetic wave. E is equal to E naught sine kx minus omega t. Okay, equation of the electric field, na? In the electromagnetic wave we have written. You can see here also. This is the equation of the electric field. I have written E is equal to E naught kx minus omega t. Okay.
Yes, sir. Yes, sir.
So energy density of electric field. Oh, this is the topic. So energy density of the electric field is this. Okay. So now we will discuss the energy density of the magnetic field. Just wait a minute. So today we will have half hour extra, okay, all of you, because in the last class I have told you that so now energy density for the magnetic field we will discuss. Energy density for the magnetic field. So energy density for the electric field, what we get? Average energy density half epsilon naught into E naught square. This we get. Energy density of the magnetic field. And suppose you have one inductor. You have an inductor like this. This is the inductor. And in this inductor, there is a current I. So if there is a current I in the inductor, so I can say there will be the magnetic field inside the inductor, and that magnetic field will be in the axial direction like this. This will be the direction of the magnetic field. So the magnetic field in the inductor is basically, this is a solenoid, you can say this is the solenoid also. Okay, so you can say the magnetic field inside the solenoid is given by mu naught into small n into I. I is the current in the solenoid, mu naught is the permeability of the free space, n is the number of turns per unit length of the solenoid. And suppose L is the length of the solenoid. L is the length of the solenoid. Now, what is the energy stored in an inductor? Energy stored in an inductor is given by half Li square. What is L? L is the inductance of the inductor. Now, from this equation, you can find the value of the current. That is V divided by mu 0 into N. Okay. Current value, and in self inductance of the inductor I have derived. Self inductance of the inductor is given by mu naught N square pi R square L. Pi R square into L. If R is the radius. if r is the radius of the solenoid. Okay, if r is the radius of the solenoid, we have derived this. Okay, in the electromagnetic induction I have derived this formula. So now we will put the value. Energy stored in the inductor is equal to half value of L is mu naught n square, mu naught n square pi r square L, pi r square L, I square means square of this I, it will become b square divided by mu naught square into n. Now see which terms are cancelling out. One mu naught is gone with one mu naught. This n is basically this will be your n square. This will be your n square. This n square will be cancelled out with this n square. Okay, so you will have the energy stored in the inductor is equal to half, and half v naught square divided by mu naught into pi r square L, pi r square L, and volume of the solenoid or inductor is equal to pi r square L, and we want energy per unit volume, that is the energy density. Energy density is energy per unit volume. So this is the energy and this is the volume, pi r square L. This is equal to v naught square divided by 2 into mu naught. So energy density of the magnetic field is equal to V naught. Oh, from where I have written V naught? Basically, this is V only, because this is magnetic field in the inductor. Okay, so this is only B square. B square. So this is basically half of, you can write half of mu naught into half of mu naught into V square. This is the energy density. Okay, of the magnetic field. So basically this is the energy density of the magnetic field. Now magnetic field is also changing with time. Magnetic field is also changing with time in the electromagnetic wave. So magnetic field is given as V is equal to V naught sine kx minus omega t. You can write this. So now put the value of magnetic field here. So you will get mu ub means the energy density of the magnetic field, half into mu naught. V square means this square, V naught square sine square kx minus omega t. Now this thing is variable. This thing is variable. Why this is variable? Because see here this magnetic field or this value is changing with time. Time is changing. So that is why this whole value is changing. That is why this is variable. So we will calculate the average value of the energy density of the magnetic field. So average value again bar of half of mu naught into V naught square sine square kx minus omega t. Remember average value of sine square any theta is equal to half for full cycle. So here you will get UV average is equal to half of mu naught, and V naught is constant. So average of constant will be constant and it will be half. So on sine square, average of sine square kx minus omega t will be half. So you will get UV average is equal to 1 by 4 of mu naught into V naught square. So this is the average magnetic density, average value of energy density for the magnetic field in the electromagnetic wave. What is this average value of average value of energy density of magnetic field. Energy density means energy per unit volume. In unit volume, what is the amount of energy contained? What is the amount of energy contained? So, okay, so write down this. All of you write down fast. And I have told you, so we will finish this class after half an hour, because in the last class I have taken the class of 1 hour only. Completed, Fawaz and Hamza? Okay, Fawaz, you can just write D in the chat box. Okay, it will save your time. And Hamza, take the screenshot, please. This thing we have discussed in the last chapter, how to take the average value. Average value of sine only, sine theta will be 0. Sine square theta will be half for the full cycle.
Sir, can you scroll little up?
Little up, okay. Fine.
Ah, yes, yes, sir, yes.
Okay. Fawaz also completed.
Yes, sir.
So basically, if someone is asking the energy density of the electric field, then you will calculate the average value of that. Okay. Okay. So write down the energy density for the magnetic field. Basically, this is a solenoid. We know already. Hamza, okay, if you want, then you can leave. Okay. If you want, then you can leave. I will take half an hour more because last class I have taken of 1 hour. If you want, then you can leave, no problem. Okay, Hamza, you can see the recorded video, okay? Okay, Hamza, we will meet in the next class now. No problem.
Can repeat.
Hamza, is your voice is cracking. Uh, okay, you can write in the chat box. No problem.
Can you,
Hmm?
sir? Can you repeat?
I am saying that if you want, then you can leave. If you are facing some internet issue and all that, you can just see the recorded video of mine of this lecture.
Sir, where is the video?
Uh, I will send you. Okay,
Sir, where?
I will send you. I will send the link on the group.
Okay. Okay.
Okay, fine. You guys note down. Completed, Fawaz?
Yes, sir.
Now, see, see here. Basically, oh, this also you have to complete. This bar mean you are calculating the average value of this function. Okay. Completed. Okay, okay, no problem for us. It's fine now.
Yes, sir. Once again.
Okay, no problem. You can take your time. I think in the next lecture it will be finished. In the next lecture it will be finished. We will start the optics. Complete it?
Sir, dual
What?
nature.
Hmm?
Dual nature.
Beta, before dual nature, there is optics. Okay?
Oh, okay, sir.
Hmm.
Sir, done, sir.
Complete it. Okay, now what we will do, we will compare the energy density of the magnetic field and energy density of the electric field. Okay, so we will now compare. Just a minute. So basically, we will find the total energy density of electromagnetic wave. Basically, in electromagnetic wave, what is there? There is one electric field, there is one magnetic field. So total energy density of field mean energy density of magnetic field plus energy density of electric field. So if we want to find the total energy density of the electromagnetic wave, then it will be energy density of electric field plus energy density of magnetic field. Okay. So now see, we will compare first the energy density of electric field and the magnetic field. So for example, I have written here the energy density of the electric field, and I am saying that I am talking about only the average energy density. What is the average energy density of the electric field? We are talking about the average only. Average energy density of the electric field, half epsilon naught into E naught square. E naught square. Okay. So okay, so there is a relation between E naught and B naught, that is equal to C. So instead of E naught, I can write C into B naught. Okay, so I can write half of epsilon naught,
Sir,
and this will
1 by
become
4. 1 by 4 epsilon naught.
oh, very good, very good, very good, very good.
Uh,
This will be 1 by 4. Very good, Fawaz. This is 1 by 4 epsilon naught E naught square, and I can write here this value. This is E naught, so it will be E naught square, it will become C naught square, B naught square. This will be C square and B naught square. B naught square, okay? Now I have told you one more formula. Speed of the light in vacuum is given by 1 upon under root mu naught into epsilon naught. And what will be the value of C naught? C naught will become 1 upon mu naught into epsilon naught. Okay. When you will do C square, so under root will be removed. Multiplied by B naught square. Now see which term is cancelling out. This epsilon naught is cancelling out with epsilon naught. So basically, what you are getting? Basically, you are getting half 1 by 4 of epsilon naught into V naught square. What is this? This is the average value of the energy density of magnetic field. So means both are equal. Energy density of electric field is equal to the energy density of magnetic field. Okay. So now for the total energy density of the electromagnetic wave will be energy density of the electric field average value plus energy density of the magnetic field average value. So you can write in terms of the electric field value or in terms of the magnetic field value. I will write in both the terms. So I am writing in terms of the electric field value. So basically this and this will be equal, so I can write it as 2 times of average value of the electric field energy density. So it will become 2 into 1 by 4 epsilon naught into E naught square. So what will be the total energy density of the electromagnetic wave? Half epsilon naught into E naught square. This is the total value of the energy density of the electromagnetic wave. So this is in terms of the peak value of the electric field. We can write in terms of the magnetic field also. See here, total energy density can be written as 2 times of energy density of the magnetic field average. And what is the energy density of the magnetic field? 1 by 4 of mu naught multiplied by b naught square. So it will become u is equal to, small u is equal to 1 by 2 epsilon mu naught into v naught square. So it will be the total energy of the electromagnetic wave in terms of the magnetic field, peak value of the magnetic field. Okay. So if someone is asking that what is the total value of the electric field in the electromagnetic wave, if someone is asking what is the total energy density of the electromagnetic wave, so you will write either this half epsilon naught E square, or you will write half epsilon naught half mu naught multiplied by b naught square. So total energy density in the electromagnetic wave is given by half of epsilon naught into E naught square is equal to half of mu naught into v naught square, and this is equal to the average energy density of the magnetic field, half of energy density of the magnetic field and half of the energy density of the electric field, where energy density of the magnetic field in electromagnetic wave is equal to the energy density of the electric field in the electromagnetic wave. So this thing you have to remember. Okay, write down. EMW means electromagnetic wave. Fawaz, completed. Fawaz,
Yes, sir.
completed?
No.
Okay, okay.
No, this one completed.
This one completed. Okay, no.
Yes.
Okay, I will tell you when we will start that. I think the reflection part is deleted. Just write down. I'm showing.
Sir, I need that last line.
Yeah, okay, just wait a minute. See the last line. This now?
Sir, more down.
More up or down?
Down, sir.
Down.
Yes.
So basically, na, you have to learn this, only this. And what is this? This is the total energy density of of magnetic wave. Completed, Fawaz and Nida, both of you. Okay, very good. Fawaz, you also completed?
Yes, sir. Yes.
Okay, now I'm sharing my screen to again, so that now Nida, see, which is deleted. Application of total internal reflection. Scattering of light is deleted. Blue color of sky and reddish appearance of sun at sunset. This is deleted. Okay. From the ray optics I am talking about. And all other things are there. Reflection of the light, spherical mirror, all these things are there. In wave optics, so we will move with respect to the syllabus. I will not go out of the syllabus. Okay. So in wave optics, deleted topic, resolving power of microscope, astronomical telescope, polarization is deleted. Plane polarized light, Brewster's law. In polarization, we have one Brewster's law. Uses of plane polarized light. Okay. There are some changes. Changes are expression for the fringe width. Okay. There will be only expression for the fringe width, that we calculate the fringe width in the interference Young's double slit experiment. So no derivation, just final expression only. Okay. And diffraction due to a single slit. Okay. Width of central maxima, qualitative treatment only. Okay. Qualitative treatment only, we will just theoretically I will tell you. So basically we will discuss that there. No problem. It's fine from the syllabus point of view. Okay, so now we will solve one question and after that this class will be finished. And I want that, okay, no problem. It's my job. Okay, so we will solve one question now. Just wait. This question will be based on the intense energy density. Question is, a magnetic field in a plane electromagnetic wave, in a plane electromagnetic wave is given by so basically we know the electromagnetic wave is made up of the oscillation of the magnetic field and the electric field perpendicularly. So magnetic field equation is given. The equation of the magnetic field is given as B is equal to 200 micro Tesla sine and 4.0 into 10 to the power minus 5 second inverse, and this is t minus x y c. Find the, they are asking, find the average energy density, find the average energy density corresponding to electric field, corresponding to electric field. Very easy question. You have to identify the omega and all that. Basically, see the equation of the wave is given, but this time the equation of the wave is given in some different format, so we have to change the equation of the wave. So this is v is equal to 200 micro Tesla sine. So I will multiply, I am multiplying this 4 into 10 to the power 5 in this bracket, so it will become 4 into 10 to the power minus 5 into t minus 4 into 10 to the power minus 5 by c into x. So now what is the equation of the magnetic field? Just we can compare, v is equal to v naught sine omega t minus kx. You can compare with this, you can compare with this. Okay, now what is the what will be the value of, according, now compare from this equation. Okay, compare from this equation. Just wait a minute, what happened here? Okay, so basically b naught, you will have b naught, so this will be v naught, and this will be omega t with t, with t here there is omega, so it will be omega. What is k? This kx, this value is k, remember. Now we can solve it easily. Now we can solve it easily, very easily we can solve it. We have the peak value of the magnetic field, we have omega, we have k. Now they are asking the energy density corresponding to magnetic field. Energy density corresponding to magnetic field is equal to total energy density divided by 2, and that is equal to half epsilon naught E naught square, half epsilon naught E naught square. Okay, there is one more way to solve it, but I am solving. There is a relation between the E naught and V naught, that is equal to C. So from here you will get the value of E naught, that is C into V naught. So you will put here, this will be half epsilon naught E naught square means C square into V naught square. Okay, C square into V naught square. Now put all the values. We have all the values. This is half epsilon naught is 8.85 into 10 to the power minus 12. Epsilon naught is equal to 8.85 into 10 to the power minus 12 into 10 to the power minus 12. And what is this C square? What is the value of the C? C is 3 into 10 to the power 8. Okay, C square means 3 into 10 to the power 8 square. V naught, what is the value of the V naught? 200 micro Tesla. 200 micro means 10 to the power minus 6 Tesla, and the square of this. And when you will solve this, you will get 8 into 10 to the power minus 3 joule per meter cube. Why joule per meter cube? Because this is the energy density, joule per meter cube. So your answer will be 8 millijoule per meter cube. Okay, so you can write the answer in this form only, no problem. So basically these relation will be used. You should know what is the value of epsilon naught. Okay, now you can note down this. and this this was the last question of this class. Basically, I think that this chapter will be finished in the last class, in the in the half of the last class, or I think in 1 hour of last class. Note down. And here c is the speed of light in air, vacuum, or free space. Fawaz completed. Okay, so Nida, complete this. And after completing, okay, we will meet in the next class. And before coming to the next class, please revise your notes properly, and we will finish this chapter in the next class. And if you want to ask any doubt regarding, then you can ask me. So actually, this is not 10 to the power minus 12. Basically, this will be 10 to the power minus 11. Sorry, 10 to the power minus 11. Change it. Change it. 10 to the power minus 11. The value of the epsilon 0, epsilon naught is 8.85 into 10 to the power minus 11. Okay, done. Okay, so we will meet in the next class now. Okay, fine.